Cisco Certified Network Associate Day 42. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Today we're going to talk about inter-VLAN routing and switch virtual interface, both of which topic we have discussed in ICND 1. But since we are following ICND 2 topic according to Cisco, we will be dealing with inter-VLAN routing and SVI again today. Without wasting much time, let's get straight into today's class. But before we go ahead, click on that subscribe button and don't forget to hit on that bell icon to get notified when we add a new video. Also, don't forget to hit that like button, which would make us very happy. We discuss a lot of topic in our series, and there are so many things that you need to remember, for which you need to improve your memory. Don't worry, we have exactly what you're looking for. Our new channel has a video to improve your memory, so click on that button or the eye icon on the top right hand corner now to take to our other video to improve your memory. For people who don't have the eye icon on the top right hand corner, look at this description below. We will have the link to that video, which will help you improve your memory and remember a lot more than what you do. For our social media contacts, we have our company contacts on the left and my personal contacts on the right, and my email address, like always, is imran.rafai@nwking.org. So like we discussed, we're going to look at two things. That would be 2.1, configure, verify, troubleshoot inter-VLAN routing, and then we're going to look at router on a stick concept and SVI, right? So this is a configure topic, so we will be looking at configuration and troubleshooting in packet tracer, right? What is SVI? SVI stands for switch virtual interface, right? SVI. So in a typical world, we have, let's say, two networks, one for sales and one for marketing. We can connect two different switches. We'll have one switch for sales and one switch for marketing. So normally, by default, when you connect devices to the switch, they are in VLAN 1, because that's the default VLAN, right? VLAN 1, and all the switches are in VLAN 1, and then you can communicate. So this computer can communicate with this computer. Absolutely no problem at all. Similarly, this can communicate with this, because that's a switch and you can communicate with each other. Now, if this computer wants to communicate with this computer, which is, let's say, if this is sales, like we discussed, and this is marketing. So if sales computer wants to communicate with marketing computer, you cannot do it because they are disconnected. There's absolutely no connection between the two. You cannot connect a wire from this switch to this switch. Technically you could, but these computers can still not communicate because they are part of different networks, right? So different IP address networks. So this is 10.0 network, this is 20.0 network, so they cannot communicate. The only way you can get them to communicate is by putting a router in between, a layer 3 device, and connect a wire from switch 1 to the router and another wire from switch 2 to the router, right? This device, since it's a layer 3 device, it can do inter-network routing, right? Which is what we learned all this while, right? So to route traffic between one network to the other, you need a layer 3 device, and that's how you do it, right? Now, what is SVI? We're coming to SVI, so just bear with me for a minute. So typically you wouldn't, typically in an office, you wouldn't have two different switches because Cisco switches are expensive. So you would have one switch, right? Normally this is a 24 port or a 48 port switch. Let's assume this is a 48 port switch. So what we would do is we would create VLANs, right? So we would create different VLANs. So let's not confuse with the color. So let me say black. So we would create VLANs. The blue VLAN is VLAN 10, and then we create VLAN 20, which is on these represented by the red. So one switch, two different networks. So you would have same networks that we had earlier, 10.0 network and 20.0 network, connected to the same switch using VLAN. And again, this device cannot communicate with this device because this is a layer 2 device, right? So we need a layer 3 device if you want to do inter-VLAN or inter-network routing, right? How do we solve this problem? We can solve this problem by using a router, right? And with a VLAN 10 port, so let's say VLAN 10, I'm gonna use blue, so I can have one interface of the router connected to a VLAN 10 interface on the switch, and another interface connected to VLAN 20 interface, right? We can do this, absolutely no problem. You can use this, and now traffic from sales would go through here, come to the router, come down, and then again go to this device, right? Absolutely no problem. Communication can happen. Now this is an utter waste of interfaces, because we are wasting two interfaces when we can make use of another concept called a router on a stick and solve this problem. Now that's something we will come back. We're talking about SVI now. SVI, like we discussed, is switch virtual interface. Now normally if you go to a new switch, all the ports are in VLAN 1, right? VLAN 1, and that's the default VLAN, and all the ports in the device is connected to VLAN 1. Also by default there is an interface, right? An interface called VLAN 1, that's a virtual interface, and this is a SVI. This is a switch virtual interface. It's a virtual interface. There's no real physical interface called VLAN 1, but there is a virtual interface called interface VLAN 1. That's a virtual interface called VLAN 1. Now what's a virtual interface? How do you typically configure a switch, right? If you're an administrator, you would have a computer, connect using console cable, you connect to a switch, you make a device. But the problem with console is you need to sit next to the device. You need to go where the switch is and connect a console cable and configure it. What if you want to remotely manage it? Let's say, for instance, you are a network administrator and you're sitting on the 5th floor. Assume you're remote, you're not sitting next to the physical device, you're sitting somewhere else, and you want to have a way to access the device. But switch being a layer 2 device, there is no IP address on the switch. There's no way you can go to each of those, let's say F0/1, and give an IP address, because layer 2 switch cannot have an IP address on the interface, right? You cannot have an interface IP address on a switch. How do you solve this problem? That is where we create a virtual interface for VLAN 1. So that's a virtual interface, right? And we give an IP address to this virtual interface, 168.1.1 or whatever. And if this network, this port, right, this computer is connected to a VLAN 1 interface, and this is a VLAN 1 interface, virtual interface, SVI, right? Then, and this, let's assume this is also in the same network, 1.10, then this computer can use this IP address to do an SSH or telnet to this device, right? That's by default, like if you're on VLAN 1. But now this computer, for our example, we have put this in VLAN 10 and this is in VLAN 20, right? So VLAN 10, you're on this network, right? Let me erase the ink. Now this is in VLAN 10 and we have an interface VLAN 1, right? Like I said, there is a virtual interface called VLAN 1. Now this device cannot access this network, this virtual interface, because that's for VLAN 1, right? So you can create a virtual interface for VLAN 10, right? Similarly, if you want this device, right, device in VLAN 20 to access this device virtually or remotely, you need to create a virtual interface for VLAN 20, and then you can give an IP address in that VLAN 20 range, and this device now can access, right? So switch virtual interface is a virtual interface given per VLAN, right? If you want VLAN 20 devices to access the switch remotely, you create a virtual interface for VLAN 20. Similarly, VLAN 10 devices, if they have to access the switch for management of whatever purpose, you need to give a virtual interface for VLAN 10, right? So virtual interface can be used for other purposes, like we will see in a while, like for routing also we can use. But understand that a virtual interface is used if you want to access that device. Virtual interface is what we use. We have discussed this earlier. I'm just using this opportunity to talk about it again so that the idea is reinforced in your minds. So there are two types, when we're talking about VLAN. We have layer 2, right? We have layer 2 and layer 3. What's the difference? We will use packet tracer to understand the difference. Right, so what I'm going to do is I'm going to take a regular layer 2 switch, right? And I'm going to put a couple of end devices. So let's say generic computer here and a generic computer here. So on the computer on the left, PC 0 will be VLAN 10 and the PC on the right would be VLAN 20, right? To make it easy, what I'm going to do is I'm just going to quickly put in all the information that we're going to do. So this is a network we're going to create. This is going to be 10.192.168.10.1. This is the VLAN 10. This is VLAN 20. Both of them will have an IP address .1. So just what we already know, I'm just going to configure normal stuff we normally do. 192.168.10.1, 255.255.255.0. For the moment, I'm not going to use gateway. We'll use that in a while. Again, same thing. 192.168.20.1, 255.255.255.0. Now, the question, will 192.168.20.1, can I ping this now? If you have reached here in our series, you should know the answer that this will not work, because even though, if you remember, even though I have not changed in the switch, I have not created, they both are in default VLAN, both of them are in VLAN 1. Both of them are in VLAN 1. So VLAN wise, no problem. They can communicate with each other's ports, but IP address is wrong, right? This is .20.0 network and this is 10.0 network. So both of those IP addresses cannot communicate, right? Physically they are reachable, but logically they're not reachable because IP address is wrong, right? Let me also go change the VLAN. So configure interface F0/1 switch port mode access switch port access VLAN 10, right? So what happened? It says access VLAN does not exist, creating VLAN 10. Okay, what just happened? Show VLAN brief. So this VLAN got created, right? It was not there because I put this port in VLAN 10, it got created there. Now, show IP interface brief. We see by default there is VLAN interface. So this is a virtual interface. This is SVI, switch virtual interface, and by default it is administratively down using the method shutdown, right? So you've gone, somebody, like by default it's gone, somebody has put that command, not somebody, by default Cisco has put a command there for shutdown. So that's why when a switch comes in, by default that interface is in administrative shutdown mode. Now let's do this. Let's go and create a virtual interface for VLAN 10, right? So this, because we put that port in VLAN 10, VLAN was created in the VLAN database. By default there was no VLAN 10, but because we put that, by default the switch said access VLAN does not exist, creating VLAN 10. So VLAN 10 was created by the device. So this is layer 2, where this is VLAN database, but this one is interface. This is layer 3. So we're going to do this. I'm going to create a VLAN 10 interface, SVI. So interface VLAN 10. So it says interface VLAN 10 change state to up, line protocol interface VLAN change state to up, right? So we can do this. Show VLAN brief. Sorry, VLAN brief obviously it has. So show IP interface brief. Now you see VLAN 10 has been created here and it is an up, right? So when you create a VLAN interface or SVI, by default it goes up. It doesn't go with the shutdown command. Remember, switch VLAN interface SVI for VLAN 1 by default is in shutdown mode, but when you create a new VLAN, by default it is not in shutdown mode, it is in up state, right? So the status is up and interface is up, right? Now let's do this. These are all troubleshooting as well. So I'm going to show you one more thing. I'm going to create, now in my VLAN database, there is no VLAN 20. VLAN 20 is not there. So let me create a layer 3, right? I'm going to create an SVI for VLAN 20. So interface VLAN 20, right? You can see that I'm in the subcommand of that interface. Now here I can say shut down if I want to shut it down, or if I want to say no shut, you just come here and say no shut, right? So if you want to enable VLAN 1, SVI VLAN 1, you have to come to interface VLAN 1 and then say no shutdown, right? But we don't have to do this. We go back. Now show interface, show IP interface brief. Now see what happened. Now VLAN 20 I've created. In previously when I created VLAN 10, automatically both of them went to up state. No problem at all. But now when I create a VLAN 20, both of them are in down state. Why is that? This is a troubleshooting technique. So this is one of the way you will troubleshoot. You will see, if you see down, you know why it could be down. It is down. In status it is down. Status is down because we don't have that VLAN, right? So we don't have VLAN 20 in our VLAN database. That's why it is in status down. So let's do this. Let's go back and create VLAN. So if you want to create layer 3, so to creating an SVI, you say interface VLAN 20. Like if you see here what we did, we said interface VLAN 20. But if you want to create a VLAN for the VLAN database, which is layer 2, we just say VLAN 20, right? So it says interface VLAN 20. Now this is an SVI. It says state change to up. That means this went to up. So let's do this. And also you see that the prompt has gone to subinterface subcommand of VLAN. Now here what you could do, you could change the name. We have discussed this earlier, but I'm going to say that again. So earlier we didn't do any name, it automatically created. So there's a default name called VLAN 10. But if you want to name it something, you say name under the VLAN subcommand, name and say sales, right? And you can go say show VLAN brief, and you see now VLAN 20 has been created. So show IP interface brief. Now VLAN 20 has gone to up. Right? So status has gone up because now VLAN database has a corresponding VLAN. But still the protocol is not up. It's still down. Why? Because it cannot see any traffic on VLAN 20. Why doesn't it see traffic on VLAN 20? Because VLAN 20 does not have any port. So obviously there's no traffic because no port is connected. Right? So we need to connect an active port. In this case, F01 and F02 are the only active port because they're the only only ports where devices are connected. So what I'm going to do, I'm going to put interface F0/2 switch port mode access, switch port access VLAN 20. Now see what happened. Line protocol on interface VLAN 20 just went to state up, right? Show IP interface brief. See, both of them went to up. So if you're troubleshooting, show IP interface, and then you see status is down, you go to VLAN database, check if the VLAN is there. Corresponding VLAN is not there, the status will always stay down. Protocol is down, you need to see if that VLAN actually has any active traffic, if there are any port associated. If there are ports associated with it, and still if there's no traffic on those ports, obviously its protocol will still be down, right? So these are the things you need to understand. Why will protocol be up? See, if you see here, all these ports F0/4 protocol is down because there's no traffic on that. It's not administratively down. If somebody had gone there and said shut down, it would be an administrative down in status, but it is down because now there's no traffic on that. So the status is also down because it's not gone to an up state because nothing is connected to it, and protocol is down because obviously there's no traffic on that. So this is one of the troubleshooting for SVI. So if you see an SVI down, you need to go look at these things to configure, right? So now Can we ping? So this is in VLAN 10 and this is in VLAN 20 and different IP addresses. Can we ping? And if you know anything of what we've learned so far, you know it will not ping because they are in different networks. So how do you get it to ping? You can get it to ping like we discussed. I can take a device. This is like obvious. I can put an IP address here, or put a router there, and take a wire, right? Connect F0/3 to one interface of the router and F04 to another interface of the router. This is standard, right? Standard procedure. It will work if I give one interface which is connected to layer VLAN 10, right? On the switch which is connected to a VLAN 10 port, which is F0/. I haven't put it, but I can. It will work. So I'm going to just quickly do that for you. All right. So what I've done is I've gone to these device, the router, and F0/1. I put an IP address from VLAN 10, like if you see here, 10. I'm going to quickly show it here so that it's easy. Because of time, I don't want to waste too much time, so I'm going to quickly cut all those parts when I'm configuring. Show IP interface brief. So you see fast Ethernet 0/0, 10.10 interface IP address. Then F0/1 is 20.10, right? So these are the IP addresses configured on the router. Let's make the required changes here. So configure terminal interface F0/3. This should be in VLAN 10. So switch port mode access, switch port access, switch port access VLAN 10, right? Interface F0/4, switch port mode access, switch port access VLAN 20, right? Now it should, or should, I don't know. What do you say? Will it work? Will this work? Let's see. Now you see that the ports in the switch are still negotiating, so it's still not gone to up. So let's just wait for a bit. Right, now the ports have gone up, so let's try that again. So you'll have an ARP miss out, and then it should ideally it should ping. Right, why is it not pinging? Let's take this to troubleshoot. Ideally it should ping. So PC goes to this port, then it goes here, comes out here. Okay, again, simple mistake, my mistake. We don't have a gateway, do we? Let's go here and we give a gateway 192.168 10.10. That's the gateway for this device. And let's go here 192.168 20.10 is the gateway for this device. Now will it ping? What do you say? Let's see if it pings. What do you say? Yes, it pings. It has to ping, right? But this is not a waste of ports. Real estate ports on routers are very scarce. You only have 2 ports, right? So you can't waste a port like this. This is like a criminal offense, so to say. So you cannot waste ports. So what do? We make use of something called as a route on stick. So let's see what are the ways we have to do routing. But before that, let's go back to the slide. So SVI, we discussed this. So if you want to create a layer 3, you need to go put the command keyword interface and then say VLAN 10. It goes to an interface subcommand, and then you can do shutdown or no shutdown. And how do we verify the interface? Show IP interface brief. That'll show you all the interfaces. Layer 2, this is nothing but a VLAN database, right? If you want to add to VLAN database, you say VLAN without the interface keyword. So just say VLAN 10 or whatever number, and go to a VLAN subcommand, and here you can do naming, right? You can say name VLAN 10, name sales, marketing, whatever. To verify, you just say show VLAN brief, and it'll show you all the VLANs. Now again, routing. How did we do routing? We discussed this earlier. You have a router, and the router connects here, and let's say even if you want to go to the internet, right, or some other network, this PC will use the router to go out, or maybe even if you want to go to the other network, that is also possible. They come here, right? So if this device wants to go to this device, that is also possible. So whatever it is, a layer 3 device is required if you have two different switches. Like I said, in typical office environment, you will have one switch. We break it down using VLANs, right? So like we discussed earlier, we have let's call it sales, and this is marketing, right? And we have two different VLANs. Now, we tried this method. We use two different interfaces. We can use that method, or we use one interface, right? So this is one interface. What you see here in blue is one interface. Let's say that is F0/0. Now we use a concept called sub interface, right? So this will be F0/0.10. This will be F0/0.20, right? And what we will do is we will make this interface. Let's say this interface is F0 slash let's say this is 01 of the switch, right? This whole blue thing is one interface, right? It's connected to one interface. Let's say that's F0/1. This is F0/2, F0/3, this one F0/4, and F0/5, right? The F0/1 interface has to be a trunk, right? It will be a trunk because now we want both these traffic, right? VLAN 10 traffic and VLAN 20 traffic to go to the router, right? And we're going to make use of only one interface of the router by using something called as a sub interface. We'll look at it in a while, but just let's understand the concept first. So we create sub interfaces, right? Again, these are virtual interfaces. They're not real interfaces. So virtually we create sub interfaces to the router by using dot, and then we make use of that. We give an IP address which is part of VLAN 10, right? And here we give IP address part of VLAN 20. Now this sub interface number, right, .10, .20, it need not, remember, it need not match with your VLAN number. It's not that, but for your convenience sake, so it becomes easy for you to remember, we do match those, but then you don't have to match it, right? So if you're troubleshooting something in your exams maybe, and then you see the number is different, don't assume that because the number is different is why it is not working. There is something else. You're troubleshooting, you need to understand that they don't need to match, so you don't have to take the trouble of changing all that, right? So that's something you need to remember. So what happens in this case? In this case, we send traffic out from VLAN 10 because it's a trunk. It will send that with a tag. They use what? If we know what we know so far, they need to use a trunk encapsulation language. So the language that we use in today's world is .1q, right? So the switch will use .1q encapsulation on trunk. It will send out those frames onto the trunk by tagging. So let's say if it's coming a VLAN 10, they put a VLAN 10 tag and send it out. What is coming on red, VLAN 20, it puts a VLAN 20 tags and sends it out. But from what we know, router does not talk this language by default, right? So we need to go tell them to talk encapsulation. So we need to go to these sub interfaces and tell them that encapsulation is using .1q, right? Once you do that, you can give an IP address. IP address for this interface, we give an IP address in this range, and for this interface, the 20 interface, we give an IP address in this range. Once you do that, communication will happen, right? Let's try that again. Right. Okay. Let me do this because I want to prove some points. I'm going to go in remove the remove the SVIs, right? So configure terminal interface VLAN 10. So I'm saying no interface VLAN 10 and no interface VLAN 20, right? So show IP interface brief. You see that VLAN 10 and VLAN 20 interfaces are out. We are still keeping the layer 2, like we're keeping in the database, in the VLAN database, VLANs are present, because if I remove that, your ports will also stop working. But we want the ports to work, but I don't want the virtual interfaces. SVIs I have removed the SVIs. Another configuration that I need to do is I need to remove these, right? I need to remove the a connection to different ports. So I'm going to just use one port of the router. So that is most probably connected to, let me just check what it's connected to. Okay, I think it's connected to, it is, yeah, F0/0, right? It's connected to F0/0 because it changed up. Now, I'm going to go, configure terminal. Interface F0/0, I'm going to say no IP address, right? No, interface F0/0, no IP address, right? Show IP interface brief, and we see that F0/0. We're not, don't bother about F0/1 now, because we're not connected. We only connected to F0/0, and that does not have an IP address. Now, to do router on a stick, your first thing is the physical interface should be in no shutdown, right? So it is in up, right? So it is not shut down. So that's first thing. And of course, there shouldn't be an IP address if you're not, typically you will not have an IP address here. The only case where you will have an IP address here is if you are, okay, let's, for the moment, just forget there's no IP address. I will come back to it. So no IP address, and this interface is in enable mode. Now interface F0/0.10, right? I'm going to say interface F0/0.10. When I do that, it creates a sub interface, right? Interface change state to up, line protocol on interface .10, right? So this is a .10 interface. We're creating a .10 interface, and that interface would, so if you go show IP interface brief, you see that it has created a new virtual interface .10, right? When you see a dot, you know it's a virtual interface. It's not a physical interface. Now, I do this every time. So just 1 minute. I'm going to cut and come back when it's ready. All right. So configure terminal interface F0/0.20, right? So we'll create a sub interface .10 and .20. So again, interface F0/0. Let's configure .10 first. So .10. Now, if you see the sub, we are in the sub interface sub command, sub if it says. If I put IP address, now I can put IP address here. IP address. It will not work, but I'm going to show you. IP address 192.168.10.10 255.255.255.0. If you hit, it will tell to configure IP routing on LAN interfaces. If you need to configure, you need to tell the encapsulation, right? It need to be ISL encapsulation or 802.1q. So we say encapsulation .1q, and we need to tell which VLAN this is, right? So this is VLAN 10, so I'm going to say encapsulation .1q and then give the VLAN number. So this is VLAN 10. Now I can go put this IP address. It will accept. Again, interface F0/0.20, same thing, encapsulation, but in this case it's 20, and then we give an IP address. It has to be 20, right? Oh, all right. So because we have interface F0/1 already have that IP address, so I'm going to say no IP address. Now if I go to F0/0.20, I can put that IP address and it will accept. Now, can we go back here and try the same thing? Can I ping from here to here? What have we done? We have, this is in VLAN 10. This is trunk. Did we create the trunk? Okay, we did not create the trunk. So configure terminal interface F0/3, right? And switch port mode trunk. So now that port is trunk. So we have done this. This is in VLAN 10. This is in trunk. This is in VLAN 20. Here I have two sub interfaces. Dot 10 is got encapsulation. I don't know if you can see. Will that overlay come? Yeah. Dot 10 is got an IP address in VLAN 10, and dot 20 has an IP address from VLAN 20. Right? Now, if I ping from here, let's just wait for this to green. Yeah, it's turned green. Now, if I ping to 20.1, will it work? That's the question. Why is it not working? Yes, it is working. Right, so it worked. What are we doing? We're doing something called router on a stick. We have one interface, which is a trunk interface. At the router's end, we have two sub interfaces talking encapsulation. Dot 1 Q language. It is routing traffic. Brilliant. Very, very, very simple. Right? This is what router on a stick is all about. Okay, so I also said that I will talk about one more thing. So let's assume now and there is another device, and I'm going to put that here, and I'm going to keep this fella in the default VLAN, VLAN 1, which is also the native VLAN for the trunk, right? Now, if this device, so I'm going to give it an IP address, let's say 192.168.30.1, 192.168.30.10 is my gateway, right? That's fine. Now, if this device wants to go and talk to, let's say, for instance, VLAN 10. Now, this is VLAN 1. What will happen? So, when this sends the traffic, the switch would send it on the trunk without tagging, because that is native VLAN, right? So, there would be no tag. How will the router respond now? The router has only two configuration. It's two sub interfaces. Those sub interfaces, one is talking VLAN 10, one is talking VLAN 20. It knows about nothing else. There are two ways we can solve this problem. One, we can go into the main interface, F0, configure terminal, interface F0/0, and then I can say IP address 192.168.30.10 255.255.255.0. We can do this. In the physical interface, I'm putting that IP address. Now what happens when traffic comes from this PC, the PC2, and goes to the switch or goes to the router, it will go without a VLAN tagging, and because I've configured that physical interface with that IP address, that will be the interface that responds, right? So now let's try this. So let's say ping 192.168.10.1, right? From here, it should go to this. Now what will happen is the switch will not tag anything because it's native VLAN. It will go to the router should send it back on this interface. For some reason it's not working. Is it working? Okay, there's something wrong. Let's quickly check the configuration. So we'll see what's done here. 192.168.30.1, 192.168.30.10. That's fine. This does it know show IP route? It knows the 30.network. It's connected directly on the thing. Did we change the show VLAN brief? This is F0/4, right? So F0/4, it's in sales. Okay, that's wrong. Interface F0/4, switch port mode access, switch port access VLAN 1, right? Now it should work. So let's see what happens. will work. Let's wait for this amber state to change to green. We could go there and say no, non-negotiate, so it will not negotiate. You could put DTP off, or you could say port fast. So there's things you could do on a real device. Just quickly. Yeah, okay, now let's try again. Okay, let's see. It should work ideally. Ideally, it should work. And that works. So the two ways, like we discussed, for native VLAN, we can go to the physical interface and give an IP address, right? Like we just did here. If you don't want to do that, let's say configure terminal interface F0/0, no IP address. Now we'll try the other method. We'll create another logical interface or sub interface. We'll call it 30, right? We do encapsulation.1q, we say 1, and we need to give a command called native, right? When we do this, it knows that this is the native VLAN, so traffic will come without any tagging, right? And then we give the IP address 192.168.30.10.255.255.255.0, no shut, which is already no shut, right? Now let's see if this works. I'm going to do this again, and it is working now absolutely perfectly, right? So these are the two ways of handling native VLAN traffic. Either physical interface, you give an IP address, or you use the keyword native in encapsulation, and then it will start working. Okay, let's go back to the presentation. So that's route on a stick. Route on a stick, you use sub interfaces, right? Now, there's another way of doing routing. So one is router on a stick. Another way, which is typically used in large environment, is you use a layer 3 device, right? So the switch that sits on here is a layer 3 switch. So what layer 3 switch can do, it does not need a router to route packets. Of course, if you want to go to an external interface, yes, you make use of a router. But for inter-VLAN routing, the switch, layer 3 switch itself, can route packet from one network to another, right? So it can go like that. So what is a layer 3 switch? A layer 3 switch, if you expand a little more, is like a mini router that sits in a layer 3 switch, right? So these devices, because it's switch, because it's in the same VLAN, right? This is one interface, this is another interface, both are in VLAN 10, so they can communicate. Then we create an SVI. This is the SVI, right? So the SVI that we need to create, interface VLAN 10, that acts like an SVI that connects to a, let's assume, to make it easy, it's actually software, but it's not a router. It doesn't have all routing functions, but it's a mini router. It can route traffic. So that SVI connects to an internal router. Then other side, again the same thing. There's an SVI, right? Interface VLAN 20 that sits on that. That's what connects to the interface. And then you have device. So devices between same VLAN will communicate no problem. If it has to communicate between VLAN 20 and VLAN 10, it doesn't have to make use of an external device. That same device is capable of doing routing, right? Only thing is we need to configure the SVIs and give an IP address in this range, right? That's something we need to do in layer 3 switching. In router on a switch, you don't have to make use of SVIs, and that's the reason I went and deleted those SVIs that we created earlier, right? So remember this, you will have a lot of videos on YouTube which says that you need an SVI for doing router on a stick. No, you don't need SVIs configured or enabled for router on a switch. For layer 3 switching, yes, you need SVI. So let's see how it works. So I'm going to delete all these devices, right? And we'll put a layer 3 device now. So layer 3 switch, we can use 3560, right? And I'm going to connect from here to here, from here to here, and from here to here. Okay. And let's do the same thing. Let's do configuration and put the appropriate VLANs. So first, interface F0/1, switch port mode access, switch port access VLAN 10. Again, VLAN will get created. Similarly, interface F0/2, switch port mode access, switch port access VLAN 20, right? And this is VLAN 1, like we did earlier. Now let's see, show IP interface brief. We have one SVI, that is VLAN 1 by default. Like I said, it's in interface administratively down state, right? Another thing is, if you're doing layer 3 switch, you need to check if the layer 3 switch routing is enabled. Most of the time routing may not be enabled, so if you do show IP route, and if you see nothing here, like everything is empty, that means routing is not enabled. Some physical switches may not even let you, it'll say that IP route is an invalid command, then you know that IP routing is not enabled. For that, you need to go to global config mode and say IP routing, right? The keyword is IP routing. When you do that, IP routing gets enabled. Now if you say show IP route, you can see at the moment nothing is there, because if you go back to our thing, we see that there is nothing configured here, right? We need to create an SVI. Once we create an SVI, then you will have a route. Now there's no route, so let's go back to packet tracer, and I'm going to create an SVI. So configure terminal, interface VLAN 10, IP address 192.168.10.10, 255.255.255.0, no shut, right? Now say do show IP route. We can see that 192.168.10.0 is directly connected through VLAN 10. Interface VLAN 20, IP address 192.168.20.10, 255.255.255.0, no shut. Now, original question, right? Can we ping 20.1? So traffic is coming from here, going into VLAN 1 port, getting out of VLAN 10 port, and going out of VLAN 20 port, because layer 2 device can now route packets. I'm not making use of a router, it is routing packets between each other. Similarly, if I want to route to layer VLAN 1, I need to go back here and enable interface VLAN 1 and say no shut. I put an IP address 192.168.30.10, 255.255.255.0, no shut. Right? Now I can ping to 30.1 also, because 30.1 would be now part of VLAN 1, and our VLAN SVI is enabled, and that will work. If I want to go to an external network, let's say for instance this router is connected to the internet, if I have to go to an external interface, this link from here to the router has to be another VLAN. So this particular port F0/4 will have to be VLAN 30, 40, whatever, a new VLAN, and you will have to give an IP address from that range to this interface, right? So any traffic that's going out, this switch will have to now route packet to the router, and then the router will route packet to that external interface, right? So it is not going to be a trunk. The connection to the router will have to be an access port, and it will be another VLAN, right? So this is how do you do layer 3 switching, right? So you have two ways of switching between inter-VLAN, right? Between VLANs to switch using router on a stick, or layer 3 switching. Layer 3 switching, you need SVIs. Router on a stick, you don't need SVIs configured. Alright, so it's been a slightly longer video. Thank you so much for watching. And like always, we will be back very soon. Now we will be getting into very important topics like OSPF and AIGRP. So stay tuned, come back very soon. Bye bye.